Hi, my name is Desiree Moore, and I will be giving our presentation over the antiviral delivery system. This is Team 10. Our project scenario was tasked to us by the World Health Organization, who has recently found a new strain of an Ebola outbreak. Our team must find a solution to the attack, which will quarantine the impacted area to a limited spread, introduce the antivirals into a well, and reduce the population of the strain over a long-term period. Here's my next team member.
So our objective for this project is to have our prototype read barcodes and then determine the pellet size and the amount of pellets that need to go into the well in order to treat the water. We also had to make our project both compact and portable in order for easy access to each well, and the overall goal of our design is to dispense the right amount of pellets and the type into each well. And now for our next team member.
More specifically, in order to accomplish our objective and goal, several constraints will serve as guidelines for the task at hand. This apparatus must have the capacity to take an input of 35 marbles, read and interpret 2 barcode strips that are fed manually, distribute approved pellets to the appropriate well, discard unsatisfactory selections into disposal, and recycle the remainders back to storage. Here's the next team member.
Hi, my name's Keelan, and so first off, our first physical design that we had created ended up being a very slow and just bulky overall design, and it also didn't allow for recirculation of marbles or our medicine for the wells. It was a flat design that had a conveyor belt that ran on top, and it would drop off marbles through an arm to sort them. The box that we had to sort the size of the marbles was also a problem, as sometimes our marbles would fall into the wrong hole before they could reach the proper sizing hole. And then also our conveyor belt being flat, it would also snag on the box itself with the pegs, or it would catch in its own design and marbles would fall off. So for our final design that we came up with, it allowed for the recirculation by angling up our design and allowing gravity to do our work, essentially. The conveyor belt brought up the marbles, and as they were going up, a sensor would read them to determine whether or not it was going to be kept or trashed. And if it was to be recirculated, it moved it off to the side, and we had a track that allowed the marble to follow the track and go back to be recirculated. Our keep cup had a trap door in it, so that way once all of the medicine had been gathered up, it was able to open up and drop them into the cup, so that way that cup could be dumped into a well and be able to circulate or treat the water. Now for our next member.
Okay, my name is Octavio. For the code, it was a very lengthy process. First, I designed a code on MATLAB. I put arbitrary numbers in the beginning because I didn't really have the project with me at the time. And after that, I figured out whenever I did get the project, it couldn't really work out with MATLAB that well because the syntax was not working very well. So I switched all that coding into LabVIEW. LabVIEW worked quite well the first 2 presentations, especially with the second one, because we did what the constraints asked us to do, and it was try to figure out which colors are which, and then distinguishing them from each other, which in a sense we did. After that, the coding process was tedious because we did have to configure our new project. Instead of sorting by color, we had to make it more simpler, more sleek, more smaller, which we did. So the coding had to do with having to distinguish which ones were trash, which ones were in accordance to the barcode, the dosage, and then which ones were also in according with the barcode were the marbles going into the recirculator. And what the code consisted of was the first three binary digits would be read and would be compared to a control, which would then in turn say something like, this color would be HDPE, white, blue, or red. After that, the next 5 digits would be read, and that array would be compared to another array saying if it was too big or too small, too big and too small, or too big, one small, etc. for those different combinations of binary digits. After that, what it would do, it would contain a code inside a while loop and a for loop, which would set a counter depending on which color and then which how many of each color, and after that it would reset the barcode and you would have to restart the process. It was very tricky in LabVIEW because of the constraints we had. LabVIEW did not really let us do many things, which were the RGB color inputs, which was most of the frustration. And now to my next engineering partner.
Thanks, Octavio. Sorry. My name is Esther. I'm sorry. We're probably gonna have to cut that part out. I'm so sorry. I'm so sorry. I'm so sorry. Sorry.
You can't say shit.
Thank you, Octavio. Among the results attained, there were a few problems with the prototype. Occasionally, the pellets would fall off the belt and onto the floor. We had the same problems with the recirculator. Some of the marbles would hit other marbles and it would cause it to get stuck. And on to the conclusion.
For the most part, our project was pretty structurally sound. It didn't mess up a whole lot as far as the physical structure. The code was the most difficult process as far as the final presentation goes, and we had it just about finished and our LabVIEW crashed several times on the day of presenting. A couple changes that we would add in the future if we were to do this project again. We would change the cardboard to a sturdier material just to have more firmness in presenting so that we wouldn't have to worry about marbles falling off or marbles getting off the track at any point. We would also change the angle converter, and the belt would work better with the angle conveyor belt to turn properly to the cups. If this were an actual presentation and if this were a real-world application, we would also want the cups to be more professional looking and act in a better way to take in dosages, and the recirculator would be held up and supported by other materials other than popsicle sticks. But for the most part, we were pretty proud of our presentation. As far as the look of the presentation, it was just about getting things to work properly was our difficulty as far as the code. Now to my next team member.
For the future, if we were to continue this project, we would want to create some sort of carrying case that would protect the insides and make it much more transportable. As it is right now, it's bulky, hard to carry around, heavy, and it's very easy to knock pieces off. With the carrying case, we would be able to enclose everything So no matter what the weather is, the conditions outside, the process will run smoothly. We'd also like to change the electrical components from Lego Mindstorm, which are very hard to come by, have to order them online, to much easier obtained circuits or other types of mechanical systems that are much easier to come by, much cheaper to buy, and easier to fix.